Have you ever wondered how the seemingly eternal sun, our trusty source of light and vitamin D, came to be, and what it's headed for in the distant future? It's not a happily ever after story, but it's certainly a fascinating one. Let's dive into the sun's life cycle, which could easily be the premise of an epic sci-fi saga, complete with stellar explosions and a gigantic red ending. Buckle up. Birth of the Sun, the nebular nursery. Our sun's story began roughly 4.6 billion years ago in what astronomers call a solar nebula, a large, rotating cloud of gas and dust left over from earlier supernova. As gravity pulled the cloud inward, the material gathered, forming a rotating disk around a dense core. This gravitational collapse was similar to squeezing a massive sponge until the pressure in the center was high enough to initiate nuclear fusion. At this point, the sun entered what we call the protostar phase. This was a turbulent era filled with jets of stellar wind sweeping away excess material, which eventually coalesced into the planets, moons, and asteroids of our solar system. The hydrogen atoms in the core fused to form helium, releasing massive amounts of energy, a key process that still fuels the sun today and ensures its continued burning. The sun's youth, entering the main sequence. Once our sun ignited nuclear fusion in its core, it officially became a main sequence star, a phase lasting around 10 billion years. This period is marked by stability, as the inward gravitational force is balanced by the outward thermal pressure from nuclear fusion. The sun's consistent energy output, thanks to the fusion of hydrogen into helium, is precisely why life was able to take root on Earth. During this phase, the sun also rotates on its axis roughly every 25 days at the equator. However, because of the sun's fluid nature, the poles rotate more slowly, creating a differential rotation that impacts magnetic activity. This differential rotation helps generate the magnetic fields that give rise to sunspots and solar flares. The solar cycle roller coaster. The sun is not always tranquil. It experiences an 11-year cycle of activity known as the solar cycle, which affects everything from satellite operations to whale migrations. Yup, even whales get involved. During the solar maximum, the sun produces heightened solar flares and coronal mass ejections, which are massive bursts of plasma. In 2024, we are nearing the peak of solar cycle 25, and it's been a wild ride already. The sun has recently released significant solar flares classified as X-class, some of the most powerful, such as an X 1.5 flare on July 28, 2024. Solar flares like these can affect Earth's magnetosphere, causing geomagnetic storms that interfere with satellite communications and power grids. These heightened periods of activity bring an increased likelihood of auroras, making them both an opportunity for photographers and a headache for telecommunication companies. The sun's midlife, fusion, and happiness. Currently, our sun is around 4.57 billion years old, which places it firmly in its middle age, right in the middle of its main sequence. During this stable period, nuclear fusion in the core converts hydrogen into helium at a rate of about 600 million tons per second. This process generates energy that radiates outward, maintaining a surface temperature of around 5,500 degrees Celsius. Interestingly, the outer atmosphere, called the corona, is much hotter, around 1 to 3 million degrees Celsius, thanks to processes that scientists are still trying to fully understand. Studies conducted using Solar Orbiter, an European Space Agency and NASA collaboration, show the increased frequency of energetic solar eruptions as the sun moves closer to the solar maximum. These observations allow scientists to fine-tune their models and predict solar weather, crucial for protecting our technology-reliant society. Helium burning. The red giant phase approaches. Once the hydrogen in the core runs out, our sun will expand dramatically and transform into a red giant. This phase, which will occur about 5 billion years from now, will be quite dramatic. The core will shrink and heat up while the outer layers will balloon outward, possibly engulfing the inner planets, including Earth. If humanity hasn't found a new planetary residence by then, Earth will become a very toasty place indeed. In this red giant phase, helium fusion will begin in the core, producing heavier elements like carbon and oxygen. This process will significantly cool the sun's outer surface, giving it a reddish hue, hence the term red giant. This cooling expansion will also affect the remaining planets' orbits, drastically altering the gravitational dynamics of our solar system. The Sun's biggest glow-up. The Sun's transition into a red giant will mark the zenith of its life cycle, swelling to hundreds of times its current size. It's estimated that the red giant Sun could extend beyond the orbit of Venus, making Earth a molten memory. During this time, it will lose a substantial amount of mass through stellar winds, forming a beautiful halo of glowing material known as a planetary nebula. These gas shells will be lit up by the core's intense radiation, providing a cosmic finale visible far beyond our solar system. Astronomers believe that such phenomena offer critical insights into the end-of-life processes for medium-sized stars like our Sun, further highlighting how every individual star contributes to the overall knowledge of the universe. Losing layers. Planetary nebula formation. The planetary nebula phase is one of the most picturesque but fleeting periods in a star's life cycle. As the Sun ejects its outer layers, these clouds of ionized gas spread into space and can be observed as colorful halos. The exposed core, which will be incredibly hot, provides ultraviolet radiation that makes these gases glow. The phenomenon will last only a few tens of thousands of years, very brief in stellar terms, but the light show will be spectacular. This process helps distribute elements like carbon, nitrogen, and oxygen into the galaxy, contributing to future star formation and even planetary systems. The very atoms that make up our bodies were once forged in such stellar events, highlighting our connection to the universe. White dwarf retirement. After the red giant sheds its outer layers, the remaining core will cool and shrink into a white dwarf. This remnant will be about the size of Earth, but with a mass comparable to that of the Sun, resulting in extremely high density. For example, 1 teaspoon of white dwarf material would weigh tons. The white dwarf will shine due to leftover thermal energy, but without ongoing fusion, it will slowly radiate away its energy over billions of years. White dwarfs offer critical data for astronomers. By examining them, we learn about the final evolutionary stages of stars and the chemical makeup of their progenitor. The Sun's white dwarf will remain a faint, cooling object, quietly drifting through the Milky Way, a reminder of what it once was. The final phase, theoretical black dwarf. Once the white dwarf has radiated away its energy completely, it will become a black dwarf, a cold, dark remnant of a once vibrant star. However, this is purely theoretical since the universe is only about 13.8 billion years old, and no white dwarf has cooled enough to become a black dwarf. Black dwarfs are thought to contain carbon and oxygen atoms densely packed together, and their existence would mark the final chapter in a star's life. Understanding this process not only completes the story of stellar evolution, but also helps refine our understanding of timescales in the universe, as we grapple with concepts that extend far beyond a single human lifespan. And that's the incredible journey of our Sun, from its humble beginnings in a cosmic nursery to its future as a spectacular red giant and beyond. If you enjoyed this deep dive into the life of our favorite star, make sure to hit that like button and subscribe to our channel for more future videos. Don't forget to turn on notifications so you never miss an update from the universe. Drop a comment below with what amazed you most about our Sun's life story. Until next time, keep looking up and stay curious.